Hi, this is the second video on reflections. Our focus on this one is going to be connected segments, what is a conjecture, and making some conjectures. And what we want to do is to play, investigate, explore, and discover the geometry. All right, let's go back to the software, and what we're going to do is reset this. Click on Reset. And there's a button over here that looks like Tools, Wrench, and so on. So click on that, and a drop-down menu appears. Click on Templates, and there's several templates that are pre-created. We're going to look at number 1, Connected Segments. So that's Tools, Templates, and Connected Segments. Now, it doesn't look like much was done when I do this, but let me go ahead and reflect this triangle about this horizontal dotted line. And you can see what was added. Something new has been added. These dashed segments here. And so I'm going to grab point C and pull this up so that the pre-image triangle is above the line of reflection and the image triangle is below the line of reflection. And what I want you to do as we explore and investigate, I want you to notice what seems to be true about these 3 dashed segments and these 3 points T, S, and U. There seems to be a relationship there. Now, right now it looks like you might jump at it, but let's just go ahead and investigate and try some things by grabbing and pulling. And if you're doing this with the software, I encourage you to do this and play on your own. Pause this and so you can play with it. Move the entire triangle, entire figure. So we've done this for a horizontal line. Let's go ahead and change the line of reflection by clicking over here. And instead of horizontal, go to vertical and see if your conjectures, what you think might be true, seem to hold true, what appears to be true all the time. And then let's change the line of reflection to be a slanted or a diagonal line. And what seems to be true about the 3 dashed segments and the points T, S, and U. So after playing, exploring, investigating, discovering, we want to make a conjecture or two. Use that word before, and in case you're not familiar with it, this is on page 1, about halfway down. A conjecture is an opinion or a conclusion based upon what is observed. So while we were doing that, what did you observe? What's your opinion? What conclusion can you make? We're hoping you can make at least 2 of them. Again, press pause as needed and resume when you're ready to go. All right, some of the conjectures that we hope you observed. First of all, it looks like these dash segments, these black dash segments that connect the corresponding vertices, seem to be perpendicular to the line of reflection no matter where the line of reflection is. So if you said that, that's a good thing. Another thing we seem to notice was that S, T, and U seem to be midpoints of these segments. It looks like A and A prime are the same distance from the pink line, but in opposite directions. Similarly for C and C prime and B prime. We also have noticed that not only are these black segments perpendicular to the line of reflection, they seem to be parallel to each other. So let's go ahead and use the software to validate our conjectures to see if it's true. So again, I'm going to ask you to click on the Tools, Templates. This time we're going to do the second template, which is Distance to Reflection Line. So that's Tools, Templates to Distance Reflection Line. Notice we've got something added here. So let's go ahead and reflect the triangle. And it's now giving us the lengths of these segments SA, SA prime, TB, TB prime, and UC, UC prime. So far it looks like it's validating, but that's just one pair of triangles. Let's look at a lot of them. So again, I'll pull point A, and as I pull it, notice what changes, what doesn't, and as our conjectures seem to be being validated. All right, changing the line of reflection. Let's try that with a vertical line. Notice when the point is on the line of reflection, the distances are 0, so that kind of makes sense there. Okay. And then if we change it to a slanted or diagonal line, we can't say the line y equals x because we really don't have a grid here to have a reference there. So we're using terms horizontal, vertical, and slanted. We will get to grids later. Notice with the slanted line, the distances aren't so very nice, but they're still equal. So our conclusions are that if you reflect a triangle about any kind of line, if you connect the corresponding vertices, the point and the pre-image and the point on the image, those segments are perpendicular to the line of reflection all the time, and the points where it crosses the line of reflection are midpoints of those segments. This concludes Reflections video number 2. Go on to video number 3, which talks about how to reflect by hand and also talks about angles and sides.